What do individual filters in convolutional layers actually learn? Imagine looking at a picture and instantly recognizing a line, a curve, or a color change. That's what convolutional filters help a neural network do. They are tiny tools inside the network that focus on specific parts of the data. Each filter is a small matrix of numbers, kind of like a tiny window. When this window slides over an image or data, it performs a calculation called a dot product. This process highlights certain features in the input, creating what we call a feature map. Think of it as a heat map showing where a particular pattern appears. In the early stages of a convolutional neural network, filters usually learn to spot simple features. These include edges that go in different directions, basic textures, or color gradients. For example, one filter might respond strongly to vertical lines, while another detects horizontal edges. As the data moves deeper into the network, filters start to recognize more complex shapes. They combine simple features from earlier layers to identify patterns like eyes, wheels, or even handwritten letters. This step-by-step building of understanding is what makes convolutional neural networks so powerful for image recognition. All filters share the same weights across the entire input. This means a filter that detects a vertical edge will do so everywhere in the image, no matter where that edge appears. This sharing of weights makes the network more efficient because it doesn't need to learn a new set of weights for every part of the image. Instead, it learns a few filters that can detect features anywhere. This is why convolutional neural networks are great at processing visual data, like photos or videos. When a filter detects a pattern, it produces an activation in the feature map. The stronger the response, the more likely that pattern is present in that part of the input. These learned filters are what let AI systems recognize faces, objects, or even handwritten notes. For example, in image generation tools like DALL-E or Midjourney, convolutional layers help the system understand visual details that make generated images look real and detailed. In natural language processing, although less common, convolutional layers can find local patterns in sequences of words or characters. Understanding what each filter learns also raises questions about fairness and bias. If the training data contains biases, the filters might learn to recognize or reinforce those biases. Being transparent about how filters work helps developers find and fix these issues. So, in simple terms, individual filters in convolutional layers learn to recognize specific features in data. They start with basic edges and textures and build up to complex shapes. This ability to detect local patterns is what makes convolutional neural networks so effective at understanding images and signals.